Welcome. In this video I'm going to show you how you can obtain various measures of quantitative variation or dispersion using Python. I'm using JupyterLab together with Python version 3.818, and in this video I'm mostly going to talk about how to obtain these measures, not so much on how to interpret them. These measures will include the variance and standard deviation, probably the most popular ones, but also things like the mean absolute deviation or even the decile standard deviation. To show you how all of this can be done, I'll need some example data, so I'm going to import pandas, so I can use their read CSV file to read the General Social Survey 2012, adjusted for some example purposes. Now, I don't need all the data, I just need one numeric field. So I'm going to be using the age field, which looked promising. So I'll remove the missing values, but there's also an 89 or older category, so I'm just going to replace those with 89. Change all the values to numeric, and that's all being done here, and store the result under scale field. Now I have my own library where I simply have a function for this, and it can just calculate all these different measures, but in this video I'm going to be not using my own library, but show you how most of them can also be obtained using other libraries. So the standard deviation, the sample and the population version are available in statistics, pandas and numpy, and the same goes for the variance. Notice that for pandas and numpy their default setting is different. So for numpy the default is actually to have the division done by the sample size, while with pandas it's actually the division is doing the sample size minus 1, and that's what this dd of actually represents. The median absolute deviation is available in SciPy, so it has a function for that, but also in stats models you can obtain the median absolute deviation. I've only seen one package that actually has a coefficient of variation in the SciPy, which they call just variation, the function. The mean absolute deviation is available in pandas as well, but it got deprecated, so it's no longer there. Alright, so here is the code for this. So I'll load in all those different functions. I gave them slightly different names so that I'm sure that it's actually using that function, and then it's all the time just a matter of filling out the scale field. And when I run this, I hopefully nicely get to see all the results. Now, for the other measures that are not available as a function in other libraries, we could do it ourselves. Just a quick check on the other ones as well. So the mean I can actually simply get from statistics library from Python. And it's actually useful to have together with the sample size, so that can be obtained using the len. The sum of the squared deviation, so you simply take every value and subtract the mean, and square the result each time, and then we can get the sample variance, which is the average of that, but we divide by minus 1, and that's because in the population the variation is probably slightly higher, so by dividing by a smaller number we get a higher result, which is then more in line with the population version. So the variance, the sample variance would be 312. If we divide it simply by the full sample size, we get the population version, and especially with large numbers the difference is not that big. The sample standard deviation is then just the square root out of that variance, and the same goes for the population version. For the mean absolute deviation, the average of the absolute deviations, we can use the absolute function, and then sum the results and divide by n. We can also do the same, but then using the median. So we can import the median function from the statistics library, and then we get simply the average deviation from the median. In some cases we can also take the median instead of the average. So here we're taking the average. We can also take the median of those deviations, and that gives us then the median of absolute deviations from the median. The coefficient of variation is fairly straightforward, the standard deviation divided by the sample size, and this is a measure that sometimes makes it easier to compare two standard deviations with each other. So it kind of puts it back on the scale that it actually came from. For the next two, the decile standard deviation, we can actually use the decile mean, and for that we need the 9 deciles, 10%, 20, 30, 40, etc. I have a whole separate video on how to actually obtain deciles, because that in itself can be done in a lot of different ways. So check out my quantiles video if you're interested in that. For this video, I'm just going to use the quantiles function from statistics library, and this should give me my decile mean. And then we use that instead of the regular mean in the calculation for the standard deviation. So the only difference with the formula we saw earlier is now instead of a regular mean, we now subtract the decile mean from each score, square the result, sum everything up, and divide by the sample size minus 1, and then take the square root. So the square root is the same as to the power of half, and that's this one. Alright, then the last of them all is then similar like the coefficient of variation. We can actually also do the this decile standard deviation and divide that by the decile mean. And that gives what Siraj Ut Dula actually called the coefficient of deviation. Alright, I hope this video was helpful, and thank you for watching.